If it's a tangent, we know a tangent will mean there's only one solution. Whereas normally, if we solve a linear and quadratic simultaneous equation, we end up with two pairs of solutions. I'm going to start by rearranging my linear equation in terms of one letter, i.e. x or y. I'm going to rearrange for positive x. So leaving positive x alone on the left-hand side. I'm going to move the negative 2y across the right. If you move a term across an equal sign, it changes sign. So the opposite of minus 2y, they have become plus 2y on the right-hand side. Hence, I've already got the 10. So now I know x is equal to 10 plus 2y. As I've got two terms, I place that inside single brackets. Substituting into my quadratic, every time I see x, I'm going to substitute x to be 10 plus 2y. So instead of having x squared, I know I'm going to have 10 plus 2y in brackets squared. And we know squared means multiplied by itself. Hence, I'm going to have double brackets. I've still got the plus y squared. And on the right-hand side, it was still equal, in this case, to 20. Expanding my double brackets, I know that 10 times 10 will give us 100. I know that 10 multiplied by 2y will give us plus 20y. I know 2y times 10 will give us another plus 20y. And 2y times 2y will give us plus 4y squared. I've still got the plus y squared. And on the right-hand side, my equation is still equal to 20. Collecting like terms on the left-hand side, well, here I have 4y squared plus y squared. They're like terms as they both end in y squared. If there's no number in front of the letter, the number is 1. So 4 lots of y squared add 1 lot of y squared, will simplify to give us 5 lots of y squared. Collecting my single letters of y, I've got 20y plus now 20y. That will simplify to give us plus 40y. And I've still got plus 100. And on the right-hand side, it still equals to 20. As I can see, I'm getting a quadratic in terms of y. I always want my quadratic to equal to 0. Therefore, I'm going to move the 20 from the right-hand side across to the left. If you move a term across an equal sign, it changes sign. So the opposite, add 20. Therefore, subtract 20 from both sides. On the left-hand side, I've still got 5y squared. I've still got the plus 40y. I know 100 take away 20 gives us 80. And on the right-hand side, 20 subtract 20 will cancel to give us 0. As I'm solving a quadratic, and here I can see all three terms are a multiple of 5. Therefore, to make my life easier, I'm going to divide the whole equation by 5, and it does not affect my solution one bit. So 5y squared divided by 5 gives us y squared. 40y divided by 5 gives us plus 8y. And 80 divided by 5 gives us 16, and that's equal to 0. Factorising my quadratic, as I have three terms, I know it's going to factorise into what we call double brackets. As the quadratic starts y squared, each bracket will start with a single y. And don't forget on the right-hand side, it's equal to 0. I want to find two numbers that multiply to give us the number term, in this case, positive 16. And the same two numbers must still add to give us the number in front of the single letter, in this case, positive 8. Well, the only two numbers that multiply to give us positive 16 and add together to give us plus 8, in this case, is going to be 4 and 4. As both brackets are the same, I always correct that as y plus 4 in brackets all squared equals to 0. As I'm solving, I now place my bracket equal to 0. So therefore, I'm going to have y plus 4 equals to 0. The opposite, add 4, therefore is subtract 4. So therefore, my only solution for y is y equals negative 4. To find my corresponding value for x, I know x is equal to 10 plus 2y. So therefore, x is equal to, leaving the 10 alone, while 2y in algebra means 2 multiplied by y. Hence, 2 multiplied by y, I just worked out y to be negative 4. Again, leaving the 10 alone, I know 2 times negative 4 gives us negative 8. And 10 subtract 8 gives us 2. Hence, my final answer is when x is 2, y is equal to negative 4.